Alright, so this is MCV4U Unit 13 bonus question. This is page 147, number 21. And number 21 states, a chord joins any 2 points A and B on the parabola whose equation is y to the power of 2 equals 4x. If C is the midpoint of AB and CD is drawn parallel to the x-axis to meet the parabola at D, prove that the tangent at D is parallel to chord AB. So let's just move to our steps. So first, I just wrote down the equation that they gave us in the question, which is y to the power of 2 equals 4x. And then I brought the power of 2 over so I could graph it in my graphing calculator. So it's y equals the square root of 4x. So when you graph it in your graphing calculator, you get a parabola that looks somewhat like this. And now the question says that we could pick any 2 points A and B. So I just picked here A, B, and then the midpoint C. So let's assume the midpoint's right here, C. They tell us that the point D is horizontal. Point D is horizontal to C and horizontal to the x-axis. So it's always going to be straight across from C. And then they ask us to prove that tangent D is parallel to points A, B. So they're trying to ask us to prove that this tangent right here, this one line that touches D at one point, is parallel to AB. So to prove that they're parallel, we know that the slope of AB has to equal the slope of tangent D. So what we're going to do now is look for the slope of AB and slope of tangent D and see if they are the same. So first we need to establish some points for our coordinates. Some coordinates for our points, A and B. So we need x and y values. So we have a y value. We're going to let y1 be the coordinate of the first point, and then we're going to let x x be in terms of y. So right here we solve for our x value by using our original equation. So our original equation is y to the power of 2 equals 4x. So we just solve for x, bring the 4 over. So y to the power of 2 divided by 4 equals x. So let y1 be the coordinate of our first point. So you know what our y value is, y1. And then in terms of y for x, so y1 to the power of 2 divided by 4. So that's point A. Once again, we do the same thing, but for point B. So let y2 be the coordinate of the second point. So we know our y value will be y2, and then once again, in terms of y for x, y2 to the power of 2 divided by 4, and that's our x value. So we have point A and point B. Now to find the midpoint, we know that we have to add both of our x values and then divide by 2, and then add both of our y values, divide by 2. So it would be y1 to the power of 2 plus y2 to the power of 2 all over 4, and then divide by 2, which is basically y1 to the power of 2 plus y2 to the power of 2 divided by 8, and then our y values. So y1 plus y2 divided by 2. So that's our midpoint right here. That's point C. Point C. Midpoint right here. Midpoint. And we're going to look back at that later. So the slope. To determine the slope of line AB, we know that it's rise over run, or y2 minus y1 over x2 minus x1. So the y coordinate of our second point minus the y coordinate of our first point, and the x coordinate of our second point minus the x coordinate of our first point. So we just plug that in. So y coordinate of our second point is y2. Y coordinate of our first point is y1. The x coordinate of our second point is y2 to the power of 2 over 4. And then minus our first x coordinate, y1 to the power of 2 divided by 4. So it's all over 4. And then if you expand that, you get 4 over y1 plus y2. And that is the slope of AB. So we know the slope of AB now, and now we need to determine the slope of tangent D. So to determine that, we need to find the derivative of the equation. So this is our original equation, and then we just use the equation to get the derivative. So we get 2y, and then y prime equals 4. solve for y prime so we can get our derivative. Y prime is equal to 4 over 2y. You simplify that and you get 2 over y. Now, this is where our visual comes in hand, because we know that D is always horizontal to C. That means the y value of both of these are always the same. Whatever y value C is at, D is at. And we know what the y value is of C because we solve for the midpoint. This is our y value right here, right here. So we know that if we plug in this y value, for our D in the derivative equation, we know what the slope of it, we know what the slope of point D is on the parabola. So we just do that right now. So that's our derivative simplified. So use y coordinate of midpoint. So we just plug in for y right here and plug in for our midpoint right here. So 2 over y1 plus y2 all over 2. And if you expand that, that is equal to 4 over y1 plus y2. And now that we determined both of the slopes, slope of AB and slope of tangent D, we can just compare them and see if they are the same, to see if they are parallel, and they are the same. So we can conclude that tangent D is parallel to line AB. And that is it.